Simultaneous equations. Hey everyone, my name is Shriy, and today I'm going to be teaching you guys how to solve a system of simultaneous equations. So, what the hell is that? Don't worry if you guys don't know, it's always great to learn. So, let's begin. A simultaneous equation is basically different equations coming together and trying to solve for a single value that makes them both happy. Here, if you were to think of this more like graphically, I tend to think more graphically because I think it's just beautiful. If I tried graphing equation 1, I might get something that looks like this, okay? I'm probably wrong, but just so you guys understand the concept, you get something that looks like this, okay? Of course, label your axi, otherwise your teacher's gonna kill you. Anyways, you get something that looks like this, with infinitely many points. Let's take this point right here, and I'm gonna guess it's probably something like that. Okay, so it's 8, 1. And if I try plugging that back in there, into the first equation, I get 8, because my x value is 8, right? X here would be 8, and my y here is 1. So I get 8 plus 3 times 1. 3 times 1 is 3. So 8 plus 3 equals 11. And guess what? That's actually right for once. So 11 equals 11. Woo! But likewise, there's millions, actually infinitely many points on this line. How do I know which one satisfies both of these? Well, here's how. If you try plotting the second one, maybe it might look something like this. Equation 2. Now, there are also infinitely different solutions to just equation 2. But, if you guys look closely, there's a solution that satisfies both. There's one that is okay with this one and this one. And that's what you're trying to find. You're trying to find the x value that works with both. Now, you might be sitting down and thinking, hey Shriy, where the hell am I going to use this in real life? You might not, but maybe it's some sort of nice, I don't know, maybe you might get like a puzzle. Maybe someone says 3 apples plus 2 bananas equals $14, and 2 apples plus 10 bananas equals 25. Find the value of an apple and a banana. Then you can find the value of apples and bananas. And that's like a common type of question that you might get on your test regarding this. So, yeah, I know that sounds pretty absurd, but stick with me, okay? I'm not crazy. So, the idea is you want to find a common point. This point is x, y. And in this video, we're going to go over different ways to find x and y. Now, how do you do it? There's a ton of different methods. Normal, unorthodox, just a ton. This one right here is graphically, when you just plot the 2 equations on your graphing calculator and just find the intersection. Pretty simple, like time efficient. But sometimes you won't be given a graphing calculator, or maybe it's just banned entirely. What do you do then? So there's a couple other methods. There's one with matrices, there's one with substitution, and there's one with elimination, and maybe probably millions of different ones. But some of them are complicated, some of them are easy, and some of them are just, efficient. So I'm going to be teaching you 2 different methods. I mean, this one I really don't need to teach you guys because you just literally just write that one and write that one, and then just press analyze graph and intersection. So, woo! But let's say you can't do that, okay? I'm going to first go over substitution. And what do you do in substitution? Now, when I say the word substitution, what do you think? You probably think of just taking something and putting it back in. And that's exactly what we do. But to start the substitution method, we first have to start isolating variables. What the hell did he just say? Yeah, isolating variables is when you just make a variable by itself. And you do this all the time. If you have something like 15x equals 5, what do? You divide by 15 on both sides. Right, 15 divided by 15 is 1, so 1x, and 5 over 15 is 1 over 3, so x is equal to 1 over 3. Woo! We just made x alone. And we're gonna do the same thing. So let's try it with equation 1. I get something like x plus 3y equals 11, right? But now if I minus 3y on both sides of the equation, because if you do something to one side, you have to do to the other. What do I get here? I get x, because 3y plus minus 3y plus 3y is 0. X is equal to 11 minus 3y. Here, I've successfully isolated the x. But, I think you guys see a problem. When I try doing it, I still get this annoying y term. Why do I get this annoying y term? Why? And it's pretty simple when you really think about it. It's because it's a function. They're related to one another. When x changes, y changes too. Look here. Like if the x changes one step, the y will change a step accordingly. And that's how functions work. And that's why you won't be able to just simply get a normal solution. But it's okay. Because now, what we can do is we can take this new relation with the isolation that we just did, and we can go put it back into the formula, into the equation, sorry. Now, if we try substituting the x back into this one, what happens? Well, let's find out. Let's try substituting back into the one that we just got the data from, right? We get 11 minus 3y plus 3y is equal to 11. That's basically 11 equals 11, because, minus 3y plus 3. What? Why? What? And it's really simple when you really understand it. You just took data, and then you just mix it around, and then you just put it back in, the thing that you took it from. Of course you're gonna get the same thing. Nothing new, nothing different. You're just gonna get 0 on both sides. Because this is 11 equals 11 is, it's just, you don't get anything out of it. That's why once we get data from the first one, we have to plug it back into the second one. So we can figure out what intersection fixes both of these equations and make them happy. So let's try it now and substitute this x value into this one. So, what do we do? 4 multiplied by x, but now we know x is this, right? Put them in brackets. 11 minus 3y, close bracket, minus 7y equals 6. Now, why the hell is he putting brackets? And I'll explain it. If you don't put brackets, you're more prone to making mistakes. Because with negative signs and stuff like that, you might just make a little tiny mistake when you're trying to distribute the 4, and then your life would just be like, oh, I did all this for what? Exactly, for what? That's why it's not worth it. But now, we put the brackets so we just don't make that silly mistake. So now we distribute the 4, so 44 minus 12y minus 7y equals 6. Now what do? Just simple math, really. We just find the like terms, which are these y's. So we have 44 minus 19y equals 6. Now we minus 44 on both sides. We get 19y equals 6 minus 44. And what is 6 minus 44? 6 minus 44 is 38. Like that. Is this, can you guys even see that? Let me just rewrite what I just wrote. So like over here, 19y equals 38. Okay, that's what I wrote down there. You guys can see that, yeah, good. You get this. But what is y? Now all we have to do is divide by 19 on one side, and we get y is equal to minus 2. Shit, this is minus. Y is equal to 2. Sorry. Yeah, see, do you see what I mean? Do you see what I mean with the minus signs? You don't want to do this. So y is equal to 2, because this is negative. Silly me. Okay, so y is equal to 2. So now we know that the y level of this point is somewhere around 2. Actually, is around 2. Now, let's try plugging this back in to the equation. So, if I plug in, you can now choose any. Both work. So let's choose the first one. X plus 3 times 2, which is 6, is equal to 11 x must be equal to 5. And that's our first solution. We have these two values. So we know the coordinates of this point that we started with, and that was the question that we wanted to answer. We know that that coordinate must be 5, 2. Yes, that realistically doesn't make any sense because that's on the negative side of the graph, and it would really look like somewhere over here. Yeah, you're right. It's just a way to just understand it. Of course, if you actually drew the graph properly, you'd get a real solution. But we're not doing it here. I'm just trying to show you how it works and just the mental thinking process. And that right there is substitution method. All right. I want you to maybe try solving a couple systems of linear equations by yourself now. Okay guys, why don't you try solving this one using the substitution method shown before. Yeah, pause the video of course. Okay, assuming you guys actually pause the video and you're not just watching this because you're watching this and you just want to see me talk, and you're paying attention and you're actually learning, let's move on and let me try solving this using the new method. And that new method is elimination method. And I'm telling you, this one's just the most fun to use because it's just like a gun. Like you just take one term out and then it just makes it simple algebra. It's really beautiful. So the idea is you want to line up your thing like this. You want the x's, you want the y's, you want this. Again, it doesn't have to be an x and y. It could be t and z. It could be alpha, beta. It could be sigma. It could be anything, yeah. All you have to do is just line them up like this. And when you finish lining them up, you want to try and make the coefficients of the first or the second equal to each other. And how do I make 1 equal to 2? Yeah, I sound crazy. I know. But trust me on this. Okay. If you guys said just add 1, you're not wrong, but I want to try doing it via multiplication. So what number do I multiply to 1 to get 2? If you guys said e squared over e and ln e plus ln e divided by e, you are right because you multiply 2. And so basically what you get when you multiply this by 2, you get 2x plus 6y is equal to 38. Just like that. Yeah, don't worry, I was just joking with that. Just don't worry. Anyways, so you get this, right? This is basically, so this is equation 1, this is equation 2. This is still equation 2 because they're the same thing. Now, what we can do is rewrite equation 1 below it, or really anywhere you want. Right, so now you have 2x plus 5. And now, all you have to do is just subtract the two equations. Just simply subtract the two equations. Yes, I sound crazy, but hear me out. Just trust me on this. So what is 2x minus 2x? Simply just 0. What is 6y minus 5y? Just y. What is 38 minus 33? Simply just 5. So y must be equal to 5. Right? Now, what do I do now? Now all you have to do is just plug y back into this or this. It doesn't really matter. But for efficiency, I'm going to plug into this one because it looks simpler. Now I have x plus 3 times 5, which is 15, is equal to 19. So x must be equal to 4. So my point is 4, 5. And that's it. That's how you do it. And if you guys got that answer, I'm really proud of you if you were able to do it using substitution. But now I'm going to give you one last question to try doing using elimination method. And look how fast that was. It was just bang. And that was with me talking and spitting nonsense. Like imagine you doing it just like, it's just that good. Okay guys, I'm gonna give you 2 questions to go. Okay, so the first one is 3x plus minus 7 is equal to minus y. Okay, that's the first part. Alongside with 3x plus 2y equals to 8. Let's go with 8. I want you guys to solve this one. It's pretty simple. I'm gonna give you a hint. The first step is to try and get the variables on one side and the constants on the other. If you do that, I can guarantee you, using one of the methods I showed in the video, I believe that you can solve it. And if you can't, always leave a comment down below. So this is the first question, question 1. And question 2, I'm gonna make it by myself. It might not be a legit question. Maybe you might get negative values, but who cares? Bob buys apples. What is? Woo? Bob buys apples and oranges. Okay. And basically, when he buys, when he buys 7 apples, right, minus 2 oranges, it roughly costs around 45. I love 45. Why not? 45. Oh yeah, this is like an O. This is like a. I'm gonna write a cursive. That looks like a Q now. Okay, maybe a huge O. That's an O, not a 0. That's an O. Okay. So 7A minus 2O equals 45. And when he buys 5 apples and maybe plus an orange this time, but don't want it. Yeah. This is not 0. This is not 0. Equals to 37 bucks. You know, let's go with dollars. What is the cost of an apple and what is the cost of an orange? Yeah, seems very silly, but I hope you guys can do this. And please let us know in the comments below. Also, give me feedback. I'd love to hear some things from you guys. Alright, see ya!